What does it mean to have a horizontal asymptote? We've already kind of talked about that, but we need to look at some more detailed cases. Let me switch to a close-up here. All right, here I've got an old water bottle filled with some dominoes just to act as weights on a rubber band. And if I pull it down and let it go, what's going to happen? Not a big surprise, right? And let's look at the height of that hook there. It's about 20 centimeters off the desk right now. If I pull it down, what happens? It's bouncing up and down, but kind of coming to rest, right? So let's graph that. By the way, I'm not saying that water bottles filled with dominoes are the most exciting thing, but more interesting would be something like a car suspension where you push down on it and it kind of wobbles and levels out. Hopefully it doesn't wobble too much. But what we just had is we started with things down low, and then they went like this and kind of wobbled, but the wobbling got less and less each time, right? So we had time going to infinity there. And would you say that what's the limit as of f of t as t goes to infinity? It was kind of coming to rest around 20 centimeters. And let me draw this with another color here. It was kind of doing that, right? So in the long run, it would have entirely stopped wobbling and it would be at 20 centimeters. So we can say that the limit is f of t as t goes to infinity is 20 centimeters because we can guarantee any small tolerance around y equals 20. If you wanted to say, I need this thing to be within and stay within plus or minus 1 centimeter, I might say, okay, wait 5 seconds. If you said I want it plus or minus 1 millimeter, I might say, okay, wait 17 seconds or something. If you want it plus or minus 0.01 millimeters, I might say wait 25 seconds. And after that, it'll never get outside whatever small tolerance you want. So we can say that this limit is 20 centimeters because we can guarantee any small tolerance around y equals 20. By waiting long enough, by saying up to this, like take this time point and all the time points after that, you'll be within that small tolerance. There's some horizontal cutoff. It goes by various names. We'll call it big N because that's useful in later calculus work. Such that if t is greater than big N, f of t is within your specified tolerance of y equals 20 in this case. So that's what it means to have a limit that as t goes to infinity or x goes to infinity of some finite value. It means you can guarantee that after some time point it will stay within a small tolerance band there. It might still keep wiggling, but at least the wiggles are small enough. So here we'd say this is a horizontal asymptote. And now that brings up a question. Can you cross a horizontal asymptote? Can a function cross a horizontal asymptote? Well, we just saw one that crosses it infinitely many times as you're going out toward infinity. So the answer is yes. In calculus class, A function can cross a horizontal asymptote. And I know that might contradict what you learned about asymptotes as a line that a function gets, or a curve, gets closer and closer to but never crosses. So this is one of the big three fundamental ways that calculus terminology is different than what you might have learned in a previous class. And it can cross it more than once. Here it crosses it infinitely many times. If you're looking for something interesting, you might try writing a formula for a function that does something like this. It's not too hard. It's kind of interesting. The other two ways that calculus terminology is different than what you might have learned before. One is about tangent lines. In calculus, a tangent line can touch the curve at more than one point, can even cross it, touch it at an infinite number of points. And in calculus class, areas can be negative if you have a negative height or negative width of a rectangle.